All right, we are back at AP Review. This is 2014 BC for response 2, and it is a polar problem on the calculator. So we're given the graphs of two polar curves, r equals 3, which I called r1 in my calculator, right, because it was the first one that was given, so I called it r1, and r equals 3 minus 2 sine of 2 theta, which I called r2 in my calculator. And I'm doing this on the window from 0 to pi, right? And this is the terrible recreation I have of the graph that they did for us, but cool. Let R be the shaded region here, right, which is inside R equals 3, and also inside R equals the 3 minus 2 sine 2 theta. So here it's inside that curve. So it's inside both is the short way of saying it. So we're looking at the area that's inside both at all times. Find the area of R. Okay, so the trick here is that there's a couple ways to do this, right? So one way to do this is, and it's totally fine because it's calculator section, so you can do what you want. The trick here is that you actually have to recognize that these two regions are different regions. This region, right here, right, from 0 to pi over 2, which is where they intersect, and you can verify that they intersect at theta as pi over 2, but if you plug in pi over 2, you're going to get a 3 for both answers. Like, this one's always a 3, and if you plug in a pi over 2 here, you're going to get 3 minus 2 sine of pi, which is 0. So sure enough, they intersect at pi over 3. So one way to do it, either way, this area is inside this curve, right? And then this area, right, this area over here is inside this curve, right? So technically, right, what you really want to do is write it as two separate integrals, but I'm going to show you why a lot of people chose not to do that in a sec. So technically what you're looking at for part A is that the area you want to find, right, this area that you want, so we're just going to write area equals, right, is 1/2 the integral from 0 to pi over 2 of this r quantity squared. So 3 minus 2 sine of 2 theta whole quantity squared with respect to theta, plus this integral, right, which will be 1/2 the integral from, from pi over 2, from pi over 2 to pi of 3 squared with respect to theta. And that's fine, and it's not wrong, and you can type it in and you get a numerical value. What you'll see if you look at the AP solution guidelines is that there's another way to do this, right? The other way to do this is to recognize that this is a 1/4 circle, right? Like, this is a quarter circle. So this answer, if you did this on your calculator, is going to end up being 1/4 pi r squared, which means that this is a 9/4 pi. So if you look at the solutions guideline for the AP, they just call this a 9/4 pi right here. Like, this red section, they call a 9/4 pi. And the reason they do that is because it's a quarter circle. So it doesn't matter which way you do it, right? So the AP has it as this 9/4 pi plus this integral. And that's fine, but you wouldn't be mathematically wrong if you wrote that it's this integral as well, right? So it's not wrong, it's just not what the AP has. If you don't see that that's a quarter circle, that's fine. So the way I'm going to type this in my calculator, right? So it's important that we know how to write this, right? But then the AP just wants your approximate answer. That said, you have to know how to type this in your calculator. So I'm not even going to use a half, I'm going to use a 0.5 because it's easier. So I'm going to do 0.5 function integrate, right? The thing that I called R2, so R2 quantity squared, with respect to theta, from 0 to pi over 2, right? And then you can either add it to the 9/4, or you can do the exact same process, but with your R1, or 9 pi over 4, or 9/4 pi, whichever way you want to say it. It doesn't matter, right? So I'm going to go ahead and do 0.5, right? Math 9, right? Vars over to y vars, and I pick polar. I want R2, right? So I pick R2, square it, which is the thing my brain always forgets, with respect to theta, from 0 to pi over 2, right? And then, again, I can either add the 9 pi over 4, which is fine, or I can do the other integral. So I could, if you feel more comfortable, I could also do the 0.5 math 9, right? I think this is the longer route, but I go to polar variables. This time I want r, which r1 rather, squared with respect to theta from, and this is going to be pi over 2 to pi, right? So either of those are fine, right? You can either do it as both of these integrals, or the first integral and then plus the 9 pi over 4. It doesn't matter. Either way you do it, you end up getting a 9.707 or 708, depending on if you round or truncate. So this is what the AP needs to see, right? Whichever of those two methods you used for the red area is fine. They don't need to see this, but you have to know how to put it in your calculator. Cool. Part B. For the curve, r equals 3 minus 2 sine of 2 theta, find the value of dx d theta at pi over 6. Okay, so you need an equation for x in terms of theta, right? And I'm not sure how much we're going to need this graph again, and I've already butchered it a little, but we're going to keep it as best as we can. All right, so part B, they want dx d theta at theta equals pi over 6. What that means is I need an equation for x with respect to theta first. So just as a reminder, if you ever have trouble converting between polar and rectangular, it's really just SOHCAHTOA and Pythagorean theorem. You have some radius, right, because here's my origin, right, it's the origin, and that radius is at an angle theta, and then this point can either be written as r comma theta in polar or as x comma y in rectangular, right? So my y and my x are labeled here, and I'm just using SOHCAHTOA to figure out the relationship between x's and y's and r's and thetas, or I'm using Pythagorean theorem. So x is r cosine theta. Now, it's better if you have this straight up memorized. That's awesome. But if you don't, you could figure that out using SOHCAHTOA and Pythagorean theorem. So once I know that, I know that in this particular problem, right, now you have two options. You can either go ahead and plug in what r is now, or you could call this r of theta and just use the chain rule when you derive your product. It's up to you. I'm going to go ahead. My preference is always to just go ahead and write the entirety of r ahead of time. So my x is r, this ugly monstrosity r, right, times a cosine of theta. So that's my x, right? Now I'm going to derive with respect to theta. So my dx d theta is going to be u, right? This whole thing is my u. This is my v. So u dv is going to be a negative sine of theta, right, plus v, which is cosine theta. Du is going to end up being, when I derive a sine, I get a cosine, right? So when I derive sine of 2 theta, I'm going to get a cosine of 2 theta times a 2 for the chain rule. So I'm going to end up with a negative 4 cosine of 2 theta, right? Now, I'm not going to clean that up even a little bit. And the reason I'm not going to clean it up even a little bit is they specifically wanted this at theta equals pi over 6, and I'm just going to plug in and clean up my numbers. It's a lot easier than trying to make this a situation where I have to do a whole bunch of cleanup in advance. So this is going to be a 3 minus a 2 sine of 2 times pi over 6 is pi over 3. So we'll clean that up in a sec, right? And then a negative sine of pi over 6, right? Plus cosine of pi over 6. And then this is going to be a negative 4 cosine of pi over 3 again, because that's what happens to pi over 6. Hang on one sec. I'm going to turn the light on because it is storming out, and it just got mad dark in here. So maybe that's a little better. All right. So now I'm just going to use my unit circle knowledge of pi over 6s and pi over 3s. So I'm going to get that. Oh, why am I going to do that? I take that back. It's a calculator section, guys. Come on, Hogan's brain. What's wrong with me? Okay, that was stupid. You ready? That was stupid. Okay, so there was no reason on the planet to do that, because I'm a moron. So I'm going to go ahead and type in as one of my r's. So I'm going to type in, that was a dumb, crazy thing to do, guys. That was a dumb, crazy thing to do. I'm going to type this guy in as my r, like R3, okay? So you can ignore this, because I'm a moron. Dumb Hogan. It's a calculator section, which is what I would totally tell anybody that did this work on my AP test. I'd be like, yo, come on, it's a calculator section, use it. Your calculator can't find a derivative in general, but your calculator can absolutely find a derivative at a point. Come on, Hogan. So I'm going to put this guy in as R3 in my calculator, right? Or I could, at this point, if you want, you could go back and just change your R2, but I think that's risky. So in my calculator, I'm going to go ahead and put 3 minus... Oh, interesting. I bet I could just do R2 times this thing. We're going to try that, because it can't hurt. So I'm going to go to vars. I'm going to go over to y-vars and polar. I'm going to pick R2, and I'm going to times that by cosine theta. We're going to see if this works. So that makes my R3 R2 cosine theta. Now, if this works, I should be able to do n derive of this thing at pi over 6 and be done. Or I can even use the graph function to derive on... Oh, I don't know if you can... Hang on. Check and see what you can do. Cool. All right. So I'm not sure if I can do it while graphing, but what I can do is do it with n derive for sure. So I'm going to quit out of this. I'm going to do math 8, right? I want to derive the thing I called R3. So I'm going to go to polar. I'm going to pick R3, right? With respect to theta, right? Because in this situation, my R3 is what I'm calling x. So I called this R3 in my calculator. So I'm going to derive R3 with respect to theta, right? R3 with respect to theta. So what I'm typing in my calculator is math 8, n derive, of R3, which was totally my x, with respect to theta, at pi over 6, and we're going to see if this bad boy does it for me, right? But I do need this relationship to be able to figure it out. So at pi over 6, we're going to see if it does it for me. We're hoping that it does. Right, and it comes out correct as a negative 2.366. So I get negative 2.366, and that's the right answer. So again, you just need to write this. You don't need to do the product rule. You don't need to break the bank on your brain, because it's a calculator problem, which I totally blanked on for a second. So if you're asked to evaluate a derivative at a point, do it with your calculator if it's on free response number 1 or 2. All right, cool. Part C, the distance between the two curves changes from, so between these two curves, changes on the window from 0 to pi over 2. Find the rate at which the distance between the two curves is changing with respect to theta when theta is pi over 3. Okay, cool. So this distance between the two curves. Now there's other ways to do it, but the easiest way to find this distance, right? So that distance is the outside radius, which in this case is this guy, right? So is my outside radius 3, which I called R1, minus my inside radius, which is the 3 minus 2 sine of 2 theta, which I totally called R2, right? So the distance is R1 minus R2, essentially, mathematically. So if I want to know the rate at which it's changing, what I essentially need to do is I need to derive both of those at so I'm going to call this, we'll call this d for distance actually, right? So I need to derive the distance with respect to theta and evaluate it when theta is, I think they said pi over 3, right? So what I'm going to do, right, I need to set up this expression for the distance. I need to say that what I want is the derivative of that, right, at pi over 3, and then I can make my calculator do it for me, right? So I'm probably going to go ahead and put this in as my R4, I'm just going to make it R1 minus R2, right? And then I'm going to do n derive of my R4 with respect to theta at pi over 3. So if I go to my R4, turn off R3, I'm going to make this vars over to y vars pic polar R1 minus vars over to y vars polar and R2, right? So R1 minus R2. Quit out of this. And look, I'm lazy. I can just hit second enter, right? I already have an n derived there. I'm going to replace the R3 with an R4. Or I honestly could have just used R3 again and changed what R3 was. And I'm going to change the pi over 6 into a pi over 3 and then hit enter. And I get negative 1.9999999 repeating, so 1.999 or negative 2, depending if you round or truncate. Cool. This is one you also could have done by hand if you want, because the 3's cancel and it turns out pretty nice. But part D. Interestingly enough, if you do it by hand, you definitely full on get a 2, but this is a 1.999 repeating forever, which is the same as a 2. All right, or a negative 1.99, same as a negative 2. All right, part D. A particle is moving along the curve, the one that's not just a circle, the r equals 3 minus 2 sine 2 theta, so that d theta dt, oh, it's turned into a related rates problem. D theta dt is 3 for all times t greater than 0. Find the value of dr dt at theta equals pi over 6. So they already gave you the equation, right? So this is now a related rates problem, right? So when we do related rates, we have a diagram and rates, but that's really not applicable here, like, because there's no need to have the diagram, right? We have an equation, but they already gave us the equation. It's r equals 3 minus 2 sine of 2 theta, right? And then we're going to derive that equation with respect to time. So dr dt equals, derivative of 3 goes away. When I derive the negative 2 sine of 2 theta, I'm going to end up getting a negative 4 cosine of 2 theta d theta dt, right? And then I'm supposed to substitute in the specific stuff I know. Well, they told me that at this moment, this is a 3, right, like all the time, and they tell me that the moment I'm plugging in, my theta is a pi over 6. So really all you're doing is plugging in these values. It's up to you. You could use a calculator to do it. Honestly, this is one that's pretty simple and straightforward based on unit circle knowledge, right, because this would be cosine of pi over 3 times a 3. So you end up getting a negative 4 times a 3, which is a negative 12, times a 1/2, So you end up getting a -6. Cool beans?